The James Webb Space Telescope, JWST, has provided the most detailed view of the universe ever captured, fundamentally altering our understanding of cosmic history. Launched in December 2021 and fully operational by mid-2022, the telescope was designed to observe the universe in infrared light, allowing it to see through dust, detect ancient starlight, and observe galaxies that formed soon after the Big Bang. In its first major observing campaign, known as the Cosmos Webb Project, JWST produced the largest and most comprehensive map of the distant cosmos to date. Within a single image, the telescope revealed more than 780,000 galaxies, some dating back over 13.5 billion years. This map not only expands the boundaries of the observable universe, but also challenges many of the core theories about how quickly galaxies formed and evolved in the early epochs of time. To understand why this is such a leap, it helps to consider what came before. For decades, the Hubble Space Telescope defined our deepest view into the cosmos. Its famous ultra-deep field, released in 2004, was created by focusing on what appeared to be a completely empty patch of sky for over 11 days. What emerged was a breathtaking image, showing around 10,000 galaxies. Some formed just a few 100 million years after the Big Bang. Each speck of light represented an entire galaxy, containing billions of stars and possibly billions of worlds. That single picture reshaped our sense of scale and led scientists to estimate that the observable universe might contain as many as 2 trillion galaxies. But Hubble, despite its achievements, was limited by its design. It could only detect visible and ultraviolet light. The most ancient galaxies, whose light has been stretched into longer wavelengths by the expansion of space, had become invisible to its instruments. To truly see the earliest eras of cosmic history, astronomers needed a telescope capable of observing in the infrared spectrum. That is precisely what the James Webb Space Telescope was built to do. With its 6.5-meter gold-coated mirror, more than 6 times the size of Hubble's, JWST was engineered to capture faint, red-shifted light from the first generations of stars and galaxies. It can see through the clouds of cosmic dust that obscure Hubble's view and detect the glow of celestial objects from the earliest moments of the universe. To put its capabilities in perspective, if Hubble's ultra-deep field were printed on a single sheet of paper, Webb's new Cosmos Webb image, at the same resolution, would stretch across a mural more than 13 feet wide and tall. The scale of that difference represents not just an improvement in technology, but a complete transformation in perspective. Where Hubble offered a narrow keyhole view of the distant cosmos, Webb provides a panoramic vista that captures the architecture of the universe across billions of years. The Cosmos Webb project was the largest observing program awarded to JWST in its first year. Over 250 hours of telescope time were devoted to scanning a region of sky 3 times the size of the full moon. Thousands of exposures were taken and carefully stitched together into one seamless image. The result is the deepest and widest view of the universe ever created, a single frame showing more than 780,000 galaxies, each at different stages of evolution. Within this extraordinary map, astronomers can trace the history of the universe from the present day back to only a few 100 million years after the Big Bang. It is not simply a snapshot, it is a window into time, allowing researchers to see the universe as it was during its earliest phases and to study how it has changed over billions of years. What JWST has revealed is not just an extension of what Hubble saw, it is an entirely new understanding of the cosmic landscape. Hubble showed us what might be compared to a single bustling block. Webb, by contrast, unveils the full metropolis, the dense galactic cores, the sprawling outskirts, and the vast intergalactic highways connecting them. For the first time, scientists can study the large-scale structure of the universe in unprecedented detail, the so-called cosmic web, an immense network of filaments and clusters that stretch across billions of light years. This structure forms the backbone of the universe, showing how matter, both visible and dark, has shaped the galaxies we see today. Among the countless discoveries in this dataset, one stands out for its peculiarity, an object astronomers have nicknamed the Infinity Galaxy. It consists of 2 galaxies colliding and forming a shape that resembles the figure 8. Most remarkable of all, a supermassive black hole appears to be forming not in the center of either galaxy, but in the region between them, something that has never been observed before. This finding hints at an entirely new mechanism for how black holes might form, suggesting that the collision of galaxies could sometimes give rise to a black hole in the space between them. Such rare, transient phenomena can only be detected when a telescope can observe such an immense volume of space at once, which until now had never been possible. Moving deeper into the image is like traveling backward in time. Light from the closest galaxies in the frame has taken billions of years to reach us, while the most distant light began its journey nearly 13.5 billion years ago. As astronomers study these layers of cosmic history, they encounter an era known as cosmic noon, which occurred about 10 billion years ago. This was the period when the universe was at the height of its star-forming activity, a cosmic golden age when galaxies were rapidly producing new stars at an astonishing rate. In these regions, JWST captures grand spiral galaxies, massive elliptical systems, and irregular galaxies caught in the act of merging. But even amid this abundance, Webb has detected surprises that challenge established theories. Some galaxies appear to have already stopped forming stars, even though models predict that they should be still highly active. Others show well-structured spiral arms, despite existing only a few billion years after the Big Bang, far earlier than such order was thought to emerge. These findings suggest that galaxy formation and evolution were happening at a much faster pace than previously believed. Deeper still, near the outermost edges of Webb's vision, lies the epoch astronomers call the Cosmic Dawn. This was a time only a few 100 million years after the Big Bang, when the first stars and galaxies were beginning to illuminate the universe. Before JWST, scientists expected this era to contain only small, faint galaxies, slowly coming into being. Gravity, they assumed, would need more time to gather enough matter to form anything substantial. Yet Webb has overturned those expectations completely. It has found an unexpected abundance of bright, well-formed galaxies in this early epoch, objects far too large and luminous to fit within existing models. The record for the most distant galaxy ever observed has been broken several times since Webb began operations. One example, designated GN-Z14-0, dates to just 290 million years after the Big Bang. Another, called MOR-Z14-2, existed only 280 million years after the universe began. These galaxies are not primitive clumps of stars. They are mature, organized systems containing heavier elements such as carbon and nitrogen. This chemical complexity means that at least one generation of stars must have already lived and died, enriching the surrounding space with elements forged in stellar cores. In other words, the processes of star birth and death were already underway within the universe's first few 100 million years, an astonishingly rapid timeline that challenges nearly every model of galaxy formation. These discoveries have left astronomers grappling with profound questions. How could such massive and chemically evolved galaxies form so early? Could the underlying physics of the early universe be different than what we thought? Perhaps dark matter played a greater role in accelerating structure formation, or perhaps our models of star formation need to be rewritten entirely. Some theorists have even proposed that these findings could hint at new physics beyond the current cosmological framework. Whatever the answer, JWST's data have forced scientists to revisit some of the most fundamental assumptions about how the universe grew from the chaos of the Big Bang into the structure we see today. Beyond its scientific impact, the telescope's discoveries carry deep philosophical weight. For the first time, humanity is seeing the universe not as a sparse void dotted with faint, distant smudges, but as a living tapestry of structure, motion, and light stretching back to the beginning of time. The sheer density of galaxies in Webb's images, hundreds of thousands in a single frame, underscores just how small our own corner of the cosmos really is. If so many galaxies can fit within one narrow patch of sky, then across the full expanse of the observable universe, there must be hundreds of billions more.
Each galaxy contains billions of stars, and many of those stars are now known to host planets. The implication is staggering. The number of potential worlds in the universe likely exceeds anything the human mind can easily grasp. This new vision of the universe is both humbling and transformative. For centuries, human understanding expanded with each new instrument that allowed us to see further, from Galileo's telescope to Hubble's mirror. Every step has reshaped our perception of existence. When astronauts first saw Earth from orbit, our planet became a single, fragile sphere, a symbol of unity and life in an otherwise dark void. Now, through Webb's eyes, even our galaxy appears as a tiny speck within an immense cosmic landscape, a reminder of both our insignificance and our connection to the grand story of creation. The James Webb Space Telescope extends that story beyond the limits of imagination. It shows us that the early universe was far more dynamic, structured, and luminous than anyone expected. The cosmos was not a slow, gradual unfolding. It was a rapid, energetic emergence of complexity.
So what is the true scale of the universe, as revealed by Webb? The answer is not merely a number, though the figures themselves are staggering. In a single image, the telescope recorded more than 780,000 galaxies, each one containing hundreds of billions of stars. Each star perhaps orbited by planets, moons, and entire systems of its own. Every faint speck of light captured in the Cosmos Webb image represents a vast island of matter, energy, and time, separated from its neighbors by millions or even billions of light years. To contemplate that scale is to recognize that our entire Milky Way, home to our sun, our solar system, and everything we have ever known, is only one of countless similar structures scattered throughout an incomprehensible expanse. Yet beyond the statistics lies a deeper realization. Webb has shown us that the universe is not only larger than we thought, but also far more mature in its earliest stages. Galaxies formed sooner, stars ignited faster, and black holes grew more rapidly than our models of physics had ever predicted. The processes that assemble galaxies, seed supermassive black holes, and enrich the cosmos with heavy elements appear to have begun almost immediately after the Big Bang. The smooth, uniform universe that theory once imagined emerging from that event now looks instead like a dynamic and rapidly organizing system, an arena where gravity and matter began building complex structures almost as soon as space itself existed. The grand timeline of cosmic evolution must therefore be rewritten, pushing the origins of order further back toward the beginning of time. This discovery reshapes not only scientific models, but also human perspective. It suggests that the ingredients for galaxies, and perhaps for life, were established astonishingly early, encoded into the universe's fabric from its first moments. If entire generations of stars lived and died within the first few 100 million years, then the seeds of planets, atmospheres, and organic chemistry may have been sown much sooner than we ever dared imagine. The cosmos, rather than unfolding slowly, may have surged into structure and complexity with breathtaking speed. The discoveries from JWST's Cosmos Webb project are, by all measures, only the beginning. Astronomers are still analyzing the immense data sets, and many of their implications remain uncertain. Each new image, each refined measurement, is revealing new puzzles. Galaxies too massive for their age, black holes too large to fit current models, and chemical signatures that shouldn't exist so soon after the Big Bang. As Webb continues its mission, scientists expect to refine their understanding of the first stars, the birth and death of galaxies, and the hidden architecture of the cosmic web that binds them all together. Yet, even now, one thing is clear. The universe revealed by Webb is not a silent void, but a thriving, structured realm, alive with motion, collision, and transformation at every scale. The telescope has not simply expanded our view of the cosmos, it has redefined what it means to look into deep space. It reminds us that discovery is not a destination, but an ongoing process, a continual effort to push back the boundaries of ignorance. Every observation opens new questions. Every revelation exposes deeper mysteries. And as Webb peers further into the dark, What we find there is not just the story of the universe, it is, in a sense, the story of ourselves, a reflection of our relentless curiosity and our capacity to seek understanding across the vastness of time and space. And perhaps the most remarkable truth of all is that even this, the largest and most detailed image of the cosmos ever made, represents only one small window on the infinite. Beyond the limits of Webb's gaze lies an even greater expanse of galaxies and stars, their light still on its way to us across billions of years. The James Webb Space Telescope allows humanity for the first time to witness the early chapters of the universe's story. What it reveals is not an ending, but a beginning, a glimpse of how the cosmos came to be and how much more remains to be discovered.